Okay, so we're going to talk about solving equations where we have to combine like terms. Hopefully you remember from the Quizlet we did on this lesson 2.1, like terms are terms like these here, 10x and 6x, and they're called like terms because they have the same variable x. Like terms could also just be two constant numbers without any variable, and those would also need to be combined. So all we have to do to solve this equation is, as we've done before, our goal at the end is to have x all by itself. And so I'm going to have to start off by saying I've got 10x and plus negative 6x or minus a positive x. Many students ask me what the difference is, and the answer is there really isn't one. This could be thought of, in other words, as 10x plus negative 6x equaling 20. And if I have 10 of something, and I add a negative 6, or I subtract a positive 6, that's going to give me 4x. And x is being multiplied times 4. So we know the way to undo that is going to be to divide both sides by 4. 4 over 4 is 1, which gives me 1x, and 20 divided by 4 is 5. Now, what we could also do, as always, is just do this check step to see is this true. If x really is 5, then 10 times 5 minus 6 times 5 should equal 20. 10 times 5 is 50. 6 times 5, is 30. And it turns out that that does equal. So it's always a good idea to do the check step. Same idea here. Our goal is going to be to end up with r by itself. And I've got 17 r's plus 3 more. In that case, that's pretty simple to do. In other words, this is like r times 17 of something and 3 of something. So you could basically think about this as just combining the number parts, and the r is just kind of hanging out on the side. So that's 20 times r equals 20. R is being multiplied by 20, so we're going to divide. And that means that 20 divided by 20 is 1, and 20 divided by 20 is 1 on the other side as well. So in this case, we get kind of a weird outcome. I took these problems right off of IXL, by the way. So you might see some that are similar. Let's run our check step real fast and see that is 17 times 1 plus 3 times 1 equals 20. Well, 17 plus 13, that equals 20. So that one definitely works. This one's a little different because we have no number here. And when we have no number, we have to realize that that actually means 1. So this is like 3s minus 1s equals 6. So again, I could say, well, I've got 3 of something, and I'm taking away 1 of them. Or I could think of it as 3 plus negative 1. Or I could think of it as I did on the last slide, 3 minus 1 of something. In this case, the something is the letter s. 3 minus 1 is 2. So 2s equals 6. Divide both sides by 2 because s is being multiplied by 2 right here. That's going to cancel. That's 1. And 6 divided by 2 is 3. So let's run the check step. As usual, I apologize. My handwriting's a little sloppy because I have to hold my hand over this without making any extra marks. Is 3 times 3 minus 3 6? Because we're saying, is it true that s equals 3? So we're just plugging that 3 in here and here. That's 9 minus 3, and that definitely is 6, which equals 6. Now, this one gets a little strange because we've got 3 terms to deal with. But if you look very closely, what you should notice is that these two right here are opposites. 5 of something and then taking away 5 of something basically cancels it out. It turns into 0. So this equation essentially is just s plus 0 equals 11. And if I add 0 to s, nothing happens. It's still just s. So this one looks complicated and confusing at first, but actually when you do the math, it's pretty simple. S equals 11. So just to be sure, let's do the check. Is 11 plus 5 times 11 minus 5 times 11, 11. So we have 11 plus, 11 plus 55 minus 55. Does that equal 11? Well, yeah, those cancel out. 11 equals 11. Okay, one last one. It looks bad. It's not as bad as it looks. Let me show you what I mean. This is basically 1p plus 2p plus 3p plus another 1p minus 6p equals 20. So we're only really interested in dealing with these numerical coefficients. Those are the numbers in front. So I'm going to rewrite this as 1 plus 2 plus 3 plus 1 more minus 6, all of that times p, because I've got 1 of p and 2 and 3 and 1 and negative 6. So I can just do this math inside the parentheses by itself and not worry about p at all. P is just sort of hanging along for the ride. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 1 is 7. 7 minus 6. We're just back to having 1p again. So if 1 times p is 20, and I do the algebra by dividing, 1 divided by 1 is p, as always it is. Anything divided by 1 is that number, and 20 divided by 1 is 20. Now to save you the aggravation, we're not going to plug 20 back in for this check step, because that would end up being a crazy amount of work. But we know from the math that we've done that this actually is an answer that makes a lot of sense.